Hi, welcome to my video on find the measure of a reference angle in degrees, part 2. This video is about when the numbers are not plus or minus a half, not plus or minus root 2 over 2, or plus or minus root 3 over 2, because these fractions are for 30, 60, 90 with a half and root 3 over 2, or 45 reference angles. But what about when we have fractions or decimals which are not these? Well, let's work on some of these. And the reference angle is still between 0 and 90 in the first quadrant. So we got some decimals. So find a reference angle for each to the nearest degree. So this time I have to use my calculator because it's not one of those special ones. So I have to plug it in as second function cos of 0.1412, and that gives me an 81.88, so to the nearest degree is 82. So what happens, if you think about your calculator, is written down as cos to the negative 1 on 0.1412, and this will give you your reference angle, but it also will give you, because it's positive, it will also give you the value of theta. So that's 82 degrees. 82 degrees. And we have another one, sine of theta is decimal 0.8. So let's put that in the calculator, clear that, and we got inverse sine of 0.8, close it off, and we get 53.13 degrees, so to the 53 is the nearest degree. And again, the reference angle, or it could be the theta, the reference angle, because it's positive, is written down as sine to the negative 1 on 0.8, and that reference angle comes out to be 53 degrees. So it's working backwards, and I did that in my previous units on trig, when we did the right triangular trig, trying to find the size of the angle. We did second function or inverse button on the calculator. Number 3, cos theta equals 3/4. So we have the reference angle is cos to the negative 1 on 3/4. And let's see what that comes out to be. Put our calculator here, clear it. So we got inverse cos 3/4. I could go decimal 75. So let's go 3 division 4 bracket, and I get 41.4 degrees. So 41 is the nearest degree. That's my reference angle. And I repeat, because this is positive, this reference angle is also one of the answers for the degree that's in the problem that we will discover later. But right now I'm just looking for that reference angle. And the sine of theta is 2.7. Let's look at the sine of theta is 2.7. Clear. So we got inverse sine of 2.7. And punch that in. And we get domain error. So that means the reference angle, it says error. And why is that? Well, that means if the reference angle is an error, that means theta does not exist, can't be. Let's explain. We drew the circle, and on the unit circle whose radius is 1, this point is 1, 0. This point is 0, 1. This point is negative 1, 0. This point is 0, negative 1. Notice that for sine is the y, the largest value for y is 1. The minimum value is -1. The largest value for cos, which is the x, is 1, and the smallest value is -1 for cos. So sine cannot be, the sine or the cos is always -1 less than or equal to x or y, whatever you want to put in here, less than or equal to 1. So those x values and the y values in trig on the unit circle now, whose radius is 1, is always, the x's and the y's are always between -1 and 1. That's why we got an error on the calculator, but it can't be done. Okay, let's continue. So we have some for practice. So you pause these now. You pause the calculator and work these out. Here we go. Find the reference angle to the nearest degree. Again, the reference angle is sine to the -1 on 0.3434. And we take our calculator, we place it here, clear it. So inverse sine of 0.3434 and close it off. Notice we got 20.08, so it's the reference angle is 20 degrees. Number 2, cos of theta is 4/9, so that means that the reference angle again is cos to the -1 on, it's 4/9, 4 divided by 9, and what does that give us? Let's check it out. So use the calculator, I'm going to clear it. Second function, cos 4 division 9 bracket, and we get 63.6, so the nearest degree is 64. 64. So we got 64 degrees. And sine is 0.7126, so the reference angle is sine to the -1 of 0.7126, and use our calculator. Here we go, clear it. Inverse sine, I could put the 0 in or not in. Oh, let's make that a 7 there. I want to make that a 7. 0.7726. So 0.7726 is 50.58, and that's close to 51. And the cos of is 5/4. 5/4 is 1 in, notice, 5/4, 5 into, that's 1 1/4, which is 1.25. So the reference angle is cos to the -1 on 1.25. And notice this is higher than 1, so this is error on the calculator. So that means the reference angle does not exist. In other words, cos, and just to show you on the calculator with that, inverse cos of 5 division 4 will give you domain error again, because the cos is got to be between -1 and 1. The most it can be is 1. The least it can be is -1, and numbers in between. But it has to be on a unit circle whose radius is 1. That's very important. So that takes us through some examples. Again, I repeat, these values are decimals, and the exact values of 30, 60, 90, or 45, 45 is plus or minus a half, plus or minus √2/2, plus or minus 3/2. But these decimals are not those fractions, so we need the calculator. And that brings us to the end of this video. If you like it, click on the like button. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.